All right, homework out. Textbooks open to page 266. Textbooks out and open to page 266. Have your homework as well. It was numbers 1 through 14 from the review. There on page 266. We've been talking about three-dimensional figures. And we talked first of all about the area all over the outside of these three-dimensional figures. What do we call that area all over?
Area or surface area?
Surface area, right. And if we took something like a prism, for instance, or even a pyramid, and we just looked at the area of the sides, not the area of the base or bases, just the area of the sides, we would refer to that as lateral area. Of course, that was the stuff that was on the quiz you took yesterday. But in yesterday's lesson, we began talking about not the stuff all over the outside. It would not like the wrapping paper of the Christmas present, if you will, but the contents thereof, right? The amount of space inside a three-dimensional figure, and that we refer to as volume. It's important to remember that anything that's a length, like a base or a height or a perimeter, that's just plain old inches, plain old feet, plain old centimeters. But if you want to find area, including lateral surface area, plain old surface area, just the area of a plane figure, area is always measured, class, in square units. Volume, on the other hand, back to Joshua, is measured in cubic units. And we had a couple of figures we looked at yesterday. We started with a box, though generally, Scott, we don't call it a box, we call it a...
No.
Well, if it's exactly the same dimensions all the way around, it would be a cube, but more generally... a rectangular prism, sorry. Couldn't hear you over somebody clearing their throat. And then what is the volume of a rectangular prism formula? V equals LW. It's very straightforward. Just multiply all three dimensions together. For a cube, then, Lana, which is a rectangular prism, we would say the volume can be calculated using the formula. V equals E cubed. We talked about the cylinder as well, Joshua. And we said a cylinder is technically not a prism, right? Because it doesn't have straight faces or plane faces all the way around. But it does have congruent bases, right? And a continuous cross section like a prism. What was the formula for the volume of the cylinder?
2 pi r. Oh wait, no.
That would be the lateral surface area of a cylinder.
2 pi r h plus 2 pi r squared.
That's the plain old surface area of the cylinder, not with the volume of the cylinder. So remember, remember we said in general, base times height equals volume, right? So for a rectangular prism, length times width is base times height. For a cube, the square is the base, that's side times side or edge times edge, times height, which is another edge. So for a cylinder, what shape is the base?
A circle.
So what's the area of the base going to be then? Area of a circle?
Pi r squared.
Pi r squared, and then we'll just multiply that by the height of the figure. And that's where you get our volume for a cylinder. We also looked at a triangular prism as well, but again, it just takes the basic base times height. Take the base of the prism times the height. And this again is my general formula. Really technically could work for all of them. It's just these we have found more specific ways to write it out. So for number 1, we have a rectangular prism, a box here. And what did you get for the volume of this enormous box? 294. Lana?
I got 2,940.
Yeah, 2,940. Maybe lost a zero there somewhere. 2,940 cubic hectometers, or hectometers cubed, which is just enormous, considering a hectometer is 100 meters already. Really big box. Number 2, back to Scott for redemption. 15-inch edges on a cube gives you
3,375 inches cubed.
good, 3,375 inches cubed. For the cylinder here with a 5-inch radius and a 12-inch height, what did you get for the volume, Joshua?
942 inches cubed.
Good, approximately. Remember, anytime we use pi, I want to use that approximate symbol. Approximately 942 cubic inches. And the number 4 is kind of a weird shape, right? It's a triangular prism. We first need to find the area of that triangle, and then multiply that area times the height. But the way they've got it laid down flat, right? So you almost have to visually stand it up on that triangular end so the 20 yards becomes the height. What did you get for your area, or for your volume, excuse me, on number 4? Lana?
550 yards cubed.
Great job. 550 yards cubed. 1/2 base times altitude, so 1/2 of 10 times 5.5, and then multiply that by the 20. Great job there. And then we get all 4 right. All right, Lana, you did.
I just missed number 2 because I forgot it was cubic, not square.
Okay, so missed the cubic inches part, but other than that, perfect. All right, and then, I'm sorry? Forgot the 0 on the very first one, but the rest of them were good. All right, number 5. A cylindrical silo, that's the adjective form of the word cylinder, right? A cylinder is a thing. Cylindrical is an adjective describing what kind of thing. A cylindrical silo has a floor with a diameter of 18 feet and a height of 25 feet. What is the volume of the silo? And I will say, for added strength, the silo will typically have a hemispherical half-sphere top to it. Not this one. It's cylindrical silo. So we don't have to worry about the little cap at the top. But it says, what's the volume of the silo? What did you get for your answer, Scott?
6,358.5 feet.
Good, approximately 6,358.5 feet cubed. Did we get that answer? The noise that made it sound like.
The 0.5%.
Okay, so it may have been a little bit of a multiplication or addition error somewhere. Let's come to you for number 6. It says a rectangular prism shipping container, giant box, is going to be converted into a home. By the way, have you seen these? You know, if you ever see a train go by and they got lots of stacks of these different box-looking things on there? Or maybe seen in fact, there was a video of a humongous transport ship that got caught in a wind or something, and it knocked a whole bunch of those containers over. But I've actually seen people, they'll take 2 or 3 of these containers, put them all together, and then make really beautiful homes inside. And from the outside, you're like, what is that dump? And you go inside, wow. But anyway, that's what's going on here. A rectangular prism shipping container will be converted into a home. The volume is given to us, 1,360 cubic feet. The floor has a floor area of 160 square feet. This is going to be a tiny home. What is the ceiling height? What did you get for this one, Josh?
I put 2, but that's probably wrong.
Yeah, how would we set this up? It's a rectangular prism, so we know we want to use this formula somehow. How will I plug stuff in here?
V equals...
Well, so the V is going to be replaced by...
1,306.
Right, that goes where the V goes. And then where does the 160 go, the floor area? Lana?
Like, on the right side.
Yeah, but where, Scott?
PLW.
The L and W together would be floor
Yeah.
area, right?
Oh.
So the 160 goes in place of both L and W. So to find the height, all we had to do here, Joshua, was divide away the 160. And, in fact, I'm not even going to fully divide a 160. I'm going to knock those zeros off and just divide by 16. I don't have my 16 times tables memorized. This is kind of in between 10 and 20, isn't it? A little bit closer to 20, though, so let's use 2 as our estimator. How many times would 2 go into 13? 6, but it's not really that close to 2, so maybe let's try 7 and see what happens. 7 times 6?
42.
7 times 1 plus 4?
11.
We subtract, we get...
24.
Ooh, you know what that means? It could have gone in one more time. So not 7, but 8, okay? And 8 times 6?
48.
Let's carry the 4. 8 times 1 plus 4? 12. And we subtract to get...
8.
Okay, so now we compare it smaller. So 8 and 8/16, or better yet, say 8.5 feet. So an 8.5 foot ceiling on this shipping container. All right, which a standard ceiling is 8 feet. So this is actually just a half a foot higher. How many have 8.5 feet? All right, great job. Questions? And number 7. Jennifer sold 2 fewer than 3 times as many candy bars as Catherine sold. We're definitely off of volume here. If the total number of candy bars they sold was 30, how many candy bars did Jennifer sell? Which of your unknowns got to be X here? Lana?
Catherine.
And Jennifer was?
3x negative 2.
Your equation was?
4x minus 2 equals 30.
Good, so 4x minus 2 equals 30. Your answer for x would have been
8.
8, and that's Catherine. It wanted Jennifer's sales, so how many candy bars did Jennifer sell?
22.
22. Did we get that answer?
Yep.
All right. Number 8. Alyssa designed a 6,280 cubic inch cylindrical glass container to hold a single plant. The radius is 10 inches. What is the tallest plant that can fit in her container? How would we set this one up? Scott? We need to use the use the volume of a cylinder formula here. So instead of the V, we'll write, which by the way, as soon as we see that, we should be thinking, 3.14 times 2 is 6.28. So we get the idea this may work out evenly, right? Is equal to pi, which is approximately, times the r squared. Well, since the r is 10, so r squared would be 100, which by the way, the 2 zeros here will simply, so let's just make it a 314 and forget about the 100, right? And then times the h, which is what we're asking for. When we divide by 314, it sure enough does work out evenly. The height should be, now it's approximate still, because we used an approximation for pi, but the height would be approximately 20 inches. So you can plant up to approximately 20 inches in that container. Do we get the 20-inch tall plant? Approximately 20-inch tall plant. Right? Does it make sense now? Very similar to what we did with the last one, where you're given the volume, given one of the other dimensions or two, and then finding the final dimension. All right, and number 9, find the lateral surface area of the silo in number 5. Remind me again, Josh, you were giving me this answer earlier, the formula for lateral surface area of a cylinder.
2 pi r h.
Good, 2 pi r h. And so going back to number 5, we've got a diameter of 18 feet. Well, if the diameter is 18, the radius is 9. And we'd already done that earlier. Of course, for pi, we'll approximate 3.14. And it said the height of the silo was 25. I'm going to go ahead and do 2 times 25 first to get 50. And 50 times 9 would be 450 times 3.14. But I'm going to knock off the 0 and move the point back 1. And then when we multiply, what do we get for our answer?
1,413 feet squared.
Good, approximately 1,413 feet squared. Questions on any of those problems? All right, and then some quick questions here. Number 10, give the abbreviation for the property that can be used to show the two triangles are similar. Lana? AA, little a, right? With the lowercase, angle. Number 11, name the 2 things that must be true for 2 polygons to be congruent. Now, Scott, yesterday we asked you about similarity. For review, what does it take for polygons to be similar?
All angles must be equal and the sides have to be proportional.
Right, equal angles, proportional sides. But here it asks about congruency, so what must be true for polygons to be congruent?
All angles must be equal and all sides must be equal.
Good. All angles, corresponding angles equal, corresponding sides equal as well. All the corresponding parts have to be equal. Write the name for any 6-sided polygon class.
Hexagon.
Area of a triangle formula, Josh.
1/2 b8.
Good. 1/2 BH and prime factorization of 36 using exponents, Lana.
2 squared times 3 squared.
Great job. 2 squared times 3 squared. Questions on that? Any questions at all on the homework? All right, flip back to page 265. I want you to do numbers 5 through 8. Page 265, numbers 5 through 8. just another minute or so to be finishing up. For sake of time, let's go ahead and take a look at these now. Number 5, given a length of 10 feet, a width of 11 feet, and a height of 7.5 feet, that gives you a volume of, Lana?
825 feet.
It isn't just you. Though she did catch herself, in all fairness to you, Lana. Not 825 cubic feet, but 825 feet cubed, correct. I would take, by the way, the 7.5, make it a 7.5. Start by multiplying that by the 10 to knock the decimal out. Now it's 75 times 11. Number 6, had to find the area of that triangular end or base times the height or depth, if you will, of the prism to get what volume? Joshua, number 6?
320 meters cubed.
All right, we're using the formula. The volume is equal to the base times the altitude, where the base, again, is this triangular shape, and then it goes up from there, right? So this is kind of the look. For this, we've got a base of 10 by 8. So the area of the triangle is equal to
8. Wait.
what is the area of this triangular base?
I only got 320 because I didn't finish it all the way.
So what should we have gotten for the area of the triangular base? 10-foot base, 8-foot altitude.
Well, for the area of the triangle, I got 300.
No, just the triangle. Just the one surface. Just the one end on the front. I went and stood it on its top. What's the formula for the area of a triangle?
1/2 the 8.
Right, 1/2 the 8. So if the base is 10 and the height is 8, what's the area of the triangle?
40.
40. All right, so we want to take that area as my base times the height, which is that 15-foot edge that they gave us. Now again, it's length of the way they've laid it out flat, but if they stood it up, that would be 15. So we should have had 40 times 15. And that would have given us our answer there of, Scott? 600 cubic meters. Should have been our answer there. Back to Joshua for redemption on number 7. We've got a 5.8 yard edge, finding the volume, and it's just a lot of multiplication. Josh, what do we get for number 7?
Volume equals 195.228.
Ooh. Lana?
195.112.
Yeah, there's so many little places you could have messed up there. I have no clue where it happened, but either addition or multiplication. That's the two things you're doing. 195.112 cubic yards should have been your answer. And then number 8, let's see, Scott, there's a shortcut we could use here. Did you see the shortcut? You're going to learn to look for 7s. Now, as a football fan, I see 7s. Because touchdown, assuming you make your extra point, which isn't always a given, everything counts by 7s, right? As soon as I see a 28, I'm like, oh, 4 touchdowns. Now, it may not actually be. They may have had some missed extra points and a field goal in there, but I just assume 28 points is 4 touchdowns, 63 points, 9 touchdowns. So I count by touchdowns. So when I see touchdowns, like 21, I see 7. And I ain't using 3.1 phonomo. I'm using 22 7s. Did anyone use 22 7s on number 8?
Well, I started to.
Started to before I said something. Okay, bravo, bravo. That's twice in a row. Now you've been the only one to see it. Great job, Josh. So I would go for a volume being pi r squared h. I would go with the 22 7s. The radius of 6 squared is 36 times a height of 21 over 1. Go ahead and cancel. I'm going to take the 22 and 3 to get 66 and multiply it that way. So we could have gotten an answer of 2076. That can't be right. What is this? 6, 9, 3, 8, 9, 1, 6, 7. 2,276. 300, I can't carry. Carry it 1. 1 plus 3 is 4. 4 plus 7 is 13. Carry the 2,376 kilometers cubed approximately. However, if you use 3.14, Scott, you get what?
Approximately 2,373.84 kilometers.
Yeah, approximately 2,373.84 kilometers cubed. Again, I knew my answer had to be like really close, within a couple of cubic meters of that. I'm like, hey, right, what am I doing wrong? I just can't carry worth a lick. Ignore me. Questions on this? Questions on this? I need more sleep at night. At least that's what I'm going to blame it on. Or old age, or senility. I don't know, one of those. I don't want to hit that yet. I can't. If I start using that now, it doesn't give me a lot of room, right? You want to save that till you're like 50 or 60 before you start claiming old age. That's why you're forgetting stuff. All right, questions on 5 through 8. Anyone get all of them right? All 4? All right, good, good. All right, questions? All right, let's take a look at numero 90. Read that for us if you would, Josh.
How many cubic toy blocks with 3-inch edges can be placed in a box that is 12 inches long, 9 inches wide, and 6 inches high?
How do you think, you're getting a picture here, there's a box, right? And then we have these little blocks, I say little, I mean good sized blocks. We want to put these blocks into the box. Sounds like something from, you ever read that Fox and Socks book?
Yes.
Yeah.
Okay, that's what it reminds me. Okay, so my kids, my little girl, okay, Chloe, sometimes in the evenings I'll read them stories and stuff, and so I'll sit down in my recliner and say, okay, Chloe, go get me a book. And then she'll start laughing, an evil laugh. Which, I know you can't imagine Chloe laughing an evil laugh, but she is my child, okay, so she has an evil laugh. And she'll look at me with that grin on her face. Say, guess what book, Daddy? And I'm like, oh no, not Fox and Socks. Yeah, try reading through that thing. I can't do it. But anyway, Mr. Knox, sir, all these blocks and box, sir. Anyway, so Chloe, I was thinking of you. All right, who knows? She may end up watching this video lesson in 9 more years. Anyway, she got a while before pre-algebra. All right, anyway, so how do we fit all these blocks in box, sir?
Like using the formula of a cube for the block.
Okay, so at your seats, do what Joshua says. Let's find the volume of a block. One block will have a volume of, anyone?
27.
27 cubic inches, right? 3 times 3 times 3, 27, right? All right, now, we also, though, Joshua, should probably find the...
Wow.
it's not just me.
Wow.
Help him, class.
Volume of the box.
The volume of the box.
Oh,
Right, we
that's
got
what
the
I was
block,
trying to
now we want the
figure out,
box.
but I was trying to worry about this shit.
And the box is what shape here?
The rectangle.
Right,
That's
so
what
there's
I was
your,
trying to figure out.
LWW. Man, I'm really struggling. LWH. I'm saying LWH while I'm running LWW. LWH, and it's a 12-inch by 9-inch by 6-inch. What does that come to? What is it?
486. No, wait, no.
That's not what I got.
648.
I got 648.
What?
I got 648 inches cubed. You got your 12 times 9 is 108 times 6 is 648 cubic inches.
I did that.
But, so this is the volume of the box. This is the volume of each individual block. So how would I determine how many blocks fit in box, sir? Back to you, sir, Mr. Knox, sir. Mr. Josh, sir. All right.
Just add them together.
So I add the volume of a block and the volume of the box. That would actually give us, if you were to fold the box closed and stick a block on top, that would give you the volume of that. That's what happened if we add them. We don't really want to add them. We want to put blocks, as many as we can, inside. What mathematical operation says how many of this can go into that?
Oh, division?
Division. So we simply divide Joshua. Well, we don't divide Joshua.
Wow.
We don't do that. That's you know, I got vicious quick. What do we divide what?
648 by 27.
At your seats, go ahead and divide. And what do we get for the number of blocks that fit in box? They had to do that. Get all those bricks and blocks that are mixed up with ticks and clocks. I'm so sorry, Mr. Knox.
Do you have that memorized?
I've read that book so many times. Let's someone talk about Tweedledums. What do you know about Tweedledums? Well, Tweedledums fight. It's called a Tweedledee battle. Tweedledee battle. My kids love the ending too. Now is your time numb? Yes. Give me a different book, kid. If I didn't love them, I wouldn't read the book to them. It's always like 7:30, 8 o'clock at night too. My brain's ready to turn off now. Why are you bringing that one? All right, what do you got, Lana?
24.
24 blocks in the box. Did you get that?
I was just about to.
27 can go into 64 2 times. With 10 left over, bring down the 8. 27 go into 4 times. There's your 24 blocks. Number 10. Read that for us if you would, Lana.
Find the volume of a moving van with a storage area that is 15 feet long, 7 feet wide, and 10 feet high.
At your seats. A little more straightforward, just finding a single volume here. By moving van, they really mean like a U-Haul truck. The box on the back of a U-Haul truck. Find the volume of that. And Lana got the answer to Josh's problem. Josh, give us the answer to Lana's problem.
1,050 feet cubed.
Good, 1,050 feet cubed. Having the same answer there on 10. Excellent. Turn back to page. I feel like I've got the wrong page numbers on my lesson plan. Yeah, I do. Let's turn ahead to page 268. Turn ahead to page 268. All right, and let's talk about some non-prisms here, okay, some other figures that don't have a consistent cross-section throughout. Let's first of all look at pyramids. It could be shown that a pyramid, if you were to take one pyramid, and instead of it coming to a point in the middle, have the point shift off to the side. The volume would be the same regardless of where the point comes. As long as the base is the same and the height is the same, doesn't matter the slant of the pyramid. Well, if you can imagine taking one pyramid and kind of shifting it like this, and another pyramid kind of shifting like this, and then leaving another pyramid and dropping it in, if you can picture this in 3 dimensions, I think you could see that you could fit 3 pyramids shifted properly within the same rectangular prism. Does that make sense? So therefore, we could say that for a pyramid, assuming there is some sort of rectangular base, and then from there all the sides coming to a point, the volume would be 1/3 of the box. Does that make sense? However, because the base could be really any shape, remember we said in general, volume is base times altitude. Well, we'll say that our volume is 1/3 base times altitude. We'll use a capital B to mean the base area times altitude. And this is your formula for any pyramid. Now, if it's a square pyramid, the area of the base will be B squared, right? If it's a rectangular pyramid, that would be length times width times height. If it were a triangular pyramid or a tetrahedron, well, that would be the area of the triangle times height, but again, 1/3 base times height. Does that make sense for your formula? If you'll make sure that's in your notes there. Slightly different from what they have written down. I think actually it's a line above what they have written down. But this is a consistent formula we can use for any pyramid. Again, if square pyramid, then yes, 1/3 B squared H for the square pyramid. Well, if you think about it, what a pyramid is to a box or a rectangular prism, a cone would be to a cylinder, right? So it makes sense then, since a cone comes to a point, like a pyramid does. For the cone, we would have to take a third of the cylinder's volume, so that the volume would be a third pi r squared h. Again, the pi r squared h is cylinder, but the cone comes to the point, giving us a third pi r squared h. And there's your formula for the volume of a cone. The last one is the fun one, and it takes the volume of a sphere and sort of breaks it down into an infinite number of tiny pyramids coming out from the center, expanding outward. You see a little bit of a sketch there on page 269, using kind of a calculus idea, giving us the volume for a sphere of 4/3 pi r cubed. The volume of our sphere, 4/3 pi r cubed. So if you'll note that formula as well. So 3 more formulas to add on. We've been throwing a bunch of formulas at you lately, but note those. Mark them in your book or write them in your book as needed. The sphere formula there, right at the end of the sphere blurb. The cone is not spelled out plainly. It's 1/3, then in parentheses pi r squared, then the h. You don't need the parentheses, just a third pi r squared h. And then again, the pyramid, they give you square pyramid. I give you generally any pyramid. Either one would work. I think they're primarily going to give you square pyramids, but I wanted you to see what it'd be for other pyramids as well. Look at the example problems, if you would. They give you a square pyramid, and you know it's a square pyramid because they only give you one base dimension. It's got to be 15 inches, right? Now note the height. It is not a slant height. The height is actually the interior height. Like if you could get inside the pyramid directly below the point and go straight down to the base. Not a slant height, but a true height there. Their base then is 15 by 15, which is 225. 1/3, 225 times the height of 22. And they get the 1650 cubic inches. Questions on the pyramid formula? Again, very similar to the cone formula. See that over on the next page there. They got a radius of 6, a height of 10. So it's going to be a third pi r squared h. Going with that radius 6 squared, it gives you the 36 times the height of 10. And I would take that 360, take a third of it to get 120, and then multiply that by the 3.14, knocking off that 0 as they showed there to knock it down to a 12 times the 31.4. Gives you approximately 376.8 cubic inches. Again, anytime dealing with pi, approximate. And then for your sphere, a 3-inch radius, again, the cubing the radius here, 4/3 pi r cubed. 27 gives you that cube. Again, you can cancel that with that thirds to get 9 times 436 times the 3.14 comes to approximately, as you see there, 113.04 cubic inches. Questions on those example problems? These are formulas I believe you should have seen last year as well, so these are not new to you. Or you say, no, we haven't seen those. You remember the other formulas we used earlier, but we get to these ones like, oh, I don't remember that.
I remember the
All right.
sphere.
Okay, so a little bit newer to you then. All right, questions at all on these then before we start practicing with them? What I would recommend to you, as we look ahead toward a test coming up next week on Tuesday, so we're 4 school days after this, 4 school days away, is make yourself a page and just list out all your formulas to keep track of them. Your area, your surface area, your lateral surface area, your volume. List them out for yourself in a place where it's easy for you to study. Questions at all though? Let's practice with these formulas that you see on the chalkboard. But first, without looking at the board, see if you can remember, so force yourself not to look up, see if you can remember the formulas. Try not to look up, see if you can remember the formulas as I taught them a moment ago. Let's just see. How's your short-term memory? Try to do it without looking up. I'll help your short-term memory by erasing them. How about that? Give it a good guess. If not, we'll correct it. We'll change what you have written down. See if you can get it from memory. All right, what did you get for any pyramid, first of all, Josh?
I put 1/3 b squared times.
Well, that would be true for a square pyramid, that base squared, assuming it's a square pyramid. So that's actually what we should have put for number 3. 1/3 b squared with a lowercase b,
Oh.
squared h should have been for a square pyramid. What about any pyramid, Lana?
E equals 1/3 capital BH.
Right, 1/3 capital BH, where the B just means the area of whatever the base happens to be. Whatever shape, whatever its area is, a third of that. The main thing to remember is if it comes to a point, 1/3. Okay, you got to remember the 1/3. So good. How about the cone, Scott?
1/3 pi r squared h.
Good. Remember cylinder, but take a third of it. A third pi r squared h. And then the sphere, Alana?
4/3 pi r cubed.
4/3 pi r cubed. Good. Anyone get all 4 from memory? All right. Make sure they're corrected now. Then it's okay. I was just curious. But yes, sir.
Square pyramid one again?
That was the 1/3 b squared h that you'd initially said. Again, we can replace the b squared with just a capital B, meaning the area of the base, if it's some other shape. All right. Now that you've got those written down, I want you to do numbers 5 through 7. Now that you've got them written down, do numbers 5 through 7 right below them. right, check your answers. Did you get 48 cubic meters, 235.5 cubic hectometers, and 904.32 cubic meters were your answers?
I got 5 and 6 right, but for some reason it did not go like that on the second.
All right. If you, how did you do, Lana?
I got 11.
Okay, go on to the next set, 8, 9, 10. How about you? Let me take a look at 7, and then I'll start you on 8, 9, 10. Let's see what we got. Oh, you canceled the 3 there to get the 72, which was good. You just forgot to ever multiply the 4.
Oh.
That's all. So if you took your answer times 4, it would come out to my answer. That's all.
Oh.
All right, go on to number, actually go ahead and finish it. Go ahead and multiply the 4 in there and then move on to 8 through 10. Yeah, all the other ones, Josh, were 1/3. So once you cancel that denominator 3 away, you don't even need the 1. But the sphere is the 4/3. So you cancel that 3 away, it's like, oh, I can't lose the 4, right? So that's why it would be so easy to lose the 4, because you're used to not needing it. So, all right, on to 8 through 10. Question on which one?
Number 9. I'm nowhere near that answer.
Did you get for your, because this is technically b squared, right? Which is 25 squared, which is 625. The height was 9, the 9 and 3 just canceled to give you the 3.
I put 25 times 2 with 50.
Oh, okay,
That's
so
what
instead
I
of
did.
squaring it to
Yeah.
get 625, you get 50. That's why your answer was so small. Okay, the other correct? This was the 3.14 pi, but I saw a height of 7, so I went 22 sevens to make my life easier.
Yeah, that one was correct, but number 9.
Did you finally see the 7 and the 22 7? You finally got it this time. Okay, good. How about you, Josh? Did you nail it again?
I
The
got
22 sevens? Should 594 would have been the answer if you
Yeah,
used
that's
22.
what I had.
Okay,
I
good.
just looked at the side one and I'm like, how did you do that?
That's if you did 3.14, which obviously I did. So that's what the book had in it. All right. Any questions at all on these? All right. So here's the game plan for tomorrow and Friday. We kind of wrap this up. Plan for a quiz Friday. Monday we do a full core review. Tuesday test. All right. No homework this evening though. The test, by the way, will include constructions. So going back to what we covered at the beginning of the semester, so we'll cover chapter 6, triangles, which was what we covered, and then constructions. So a couple of non-chapter 6 topics as well. All right, but now homework, you are dismissed.